Good afternoon. I'd like to welcome you to the Past Business Analytics virtual chapter. Want to make sure that you're aware of our chapter website, which is bavc.sequelpass.org. If this is your first time joining us today, make sure you follow us on Twitter under Past BAVC, and also on the PASS website, you have the ability to join the virtual chapter. Doesn't cost anything. With that, you'll get notifications of any future meetings that we have. We're going to take a break mid-month, as most of us are going to be heading off to the PASS Summit. There's going to be a lot to do there, and I believe on opening night there'll be tables for the virtual chapters, so you can come see me, Melissa Demsack, at the PASS virtual chapter tables, and also in the main pavilion there's going to be tables for the community. And Wednesday through Friday at the PASS Summit, I'm going to be available from 3 to 4 o'clock. So if you'd like to meet me or talk more about the PASS virtual chapter, I will be there. I also want to thank you for taking the poll, if you did. It's always great for presenters to find out about their topic that they're presenting about and what people are using. So as part of the poll, we saw that 21% of people are currently using predictive analytics, 71% plan on using in the next 12 months, and 8% have no plans. So for the 71% of you, this is a really great place to start, and FuzzyLogix will be providing you, with some good content on this. I'd like to welcome 3 folks that are going to help with the presentation today in some way or fashion. We have Michael Upchurch, who is the founder and CEO of FuzzyLogix. We have Alex DiPaolo, who will be doing most of the demos, and Jim Zhang will also be there in the background helping out with this. I'd like to pass the presentation at this time on to Michael to talk about his company and to kick off the actual meeting and content.
Thank you, Melissa. I really appreciate it. I appreciate all your help and all your help organizing all of these sessions. And I'd like to thank everyone for joining today. It's really a pleasure to be here with you. Please feel free to put your questions in the chat window. We will have a Q&A session at the end, but as the questions come during the session, please feel free to post them. I want to also say that today we're going to discuss how you can leverage CLR UDFs for fast analytics on big data. And since Melissa mentioned the PASS Summit, I'll also let you know that we're going to be there at booth 621. So if you see something today you have questions about and you're attending the event, please come by. We'd be more than happy to discuss it in some detail, and look forward to seeing everyone at the event. Looks like it's going to be really fun. We're headquartered in Charlotte, so we're excited to finally have a trade show, somewhere we actually don't have to travel. So that's the topic. Here's what we're going to do. We're going to cover a little bit of background. We're going to cover a little bit of background of how this is being used today in companies, a little bit about our company. Then we're going to dive into understanding CLR UDFs, where we're actually going to show you how to write your own and deploy it and run it. And then we're going to show some examples. I've also included a list of available models if we have questions about that. So when we get to the examples, we'll show the theory at the beginning and the business case, and then we'll dive into the actual use cases and the code and the technology after that. Here's a story of FuzzyLogix. We were founded after 12 years of research and development, and I show this slide so you can understand our experience in this area. First, we ported our library to Netezza, and you'll see what that library is in just a little bit. And since then, we've ported it to 7 other platforms. Others are in the works. We're going to port to Hadoop as well. And I mention this because we're the only vendor of in-database models, or CLR UDFs, on multiple platforms. And this really means enterprises can use the same models in different environments. And many of our clients do that. I mean, Raymond James is a great example of a client that started with SQL Server but also uses us in other platforms. Since a lot of people on the call are quite technical, I'll just mention, since it's worth knowing about the existence of these things, we also ported our library to run in graphics processing units. And these GPUs, they're mind-blowing. They're small cards that have up to almost 3,000 cores. And for computationally intensive calculations, there's just no faster way to run these types of analytics than GPUs. So here today, we're going to talk about CLR UDFs, which are great for big data and for most computationally intensive things. But when things get a little in this sort of grid space, the GPU is an emerging technology to be aware of. And finally, as a company, I'll mention that we offer consulting and custom model development. So we have a long background in this. We have a lot of clients. We're considered by Forrester and Gartner to be the leader in this space. And we're happy to teach people how to write their own CLR UDFs, but of course we also offer our own libraries out in the market. So with that, let's jump into the theory of why you'd use a CLR UDF. Here we have a traditional, probably simplified view of analytics the way they're done in the market. And what happens is most companies store data in one place, and then they move it somewhere else to analyze it. And there's some reasons for this. Historically, databases stored data, and they weren't that powerful. So then you move the data over to some middle tier, such as a SAS server or iServers or cubes for analysis. Frankly, that's where the models were available. But in the last few years, there's been a lot of change in database technology. And what's happened is databases have become much more powerful. Databases have also had to deal with some enormous exponential growth in data sizes. And so in the last few years, the database became more powerful, the data got larger, but companies also introduced or improved the ability to build things like CLR UDFs. So in the scenario on this side, what you see is a lot of data movement. You see we have a middle tier for analysis, and you see the data moving amongst all the systems. But this does create some issues. These issues are that the middle tier will never practically be larger than the database. It's almost impossible to scale that middle tier to the size of a data warehouse. It's cost prohibitive. And moving that data can account to up to 80% of the time for analytics. So what happens is you spend 80% of your time moving analytics and 20% of your time doing analytics. In these scenarios, you also have duplicate file storage, additional data center space, security, on and on. So what we're kind of proposing is a more elegant model that kind of simplifies this and improves performance and scalability. That looks like this. It's a much simpler model. And what you see is that we've taken the analytics via CLR UDF, and this is something you can do as well, and we've vastly reduced the amount of data movement. I guess let me just say I don't think anyone's going to eliminate their middle tier completely. But what can happen is that much of the data processing can move back to the database. And that'll take some load off that middle tier and possibly allow for a smaller instance of it. And in some cases, such as if that middle tier is a SAS server, there's cost savings involved with not having that middle tier grow. There's also tremendous performance benefits, which we'll see in a minute. In this model, data movement is minimized and performance is enhanced. Simply due to the data movement, but also due to the incredible growth in processing power that databases have gained. I'll give you a quick example of this. So in the previous slide, it would be something like where you had a MicroStrategy iServer in the middle. In this slide, this is an example of pushing the analytics, not in that iServer, but down into the database. We tested that. We saw a 91% improvement in performance. So there's huge benefits for customers in size, scale, and performance. And I think these benefits will hold true for any middle tier environment. When you can eliminate that and push the processing back to the database, you get tremendous savings. There's one more advantage that you get here, and that is if you have a robust set of CLR UDFs in your database, then you can roll out analytics to your end users. And this lets you do things like give them the ability to run forecasts with their sales teams, or allow them to execute CLR UDFs from their existing reporting tools to get those forecasts. And that becomes very powerful because, again, with a lot of those middle-tier solutions, they come with their own proprietary front end. And you probably already have an existing reporting environment, either a tool you buy or something you built. And, the last thing you need your end user or your end user wants is yet another type of technology on their desktop. It's usually pretty full. So, talk about being able to roll this out, but I can show you what that looks like. So as we go from this theory of simplification and moving less data, let's look at sort of practically at a high level how you might use it. In this example, we're asking the question, what is the correlation of stock returns in a portfolio? And here you can see this is a simple SQL statement we use to call the CLR UDF. In this case, the name of the CLR UDF we built is FL Corel. It's in orange on your screen. And the deal is that this statement really could be dynamically built by end users running front-end tools. They could basically select their variables and then execute the models, or select their stocks and push the models on their portfolio. Here on the right-hand side, you see the red, yellow, green screen. What that is, that's the results displayed in an iPad, where the user simply, they selected their portfolio of stocks and ran the analysis. And in this case, the only data moved was a small set of data, which allowed the user to pick their portfolio. Computation happened in the database, and then the results that moved. So that benefit of being able to roll out analytics inbuilt into existing reporting tools is very powerful. Like I said, it eliminates the need for a second tool, but it also lets your organization sort of digest analytics at the speed which you can operationally do that without having some massive project to put in an entire new system. There's a way to slowly build your organization into using analytics. And I'll mention in this demo, we're actually using 42 billion rows of data. It's a huge set of trading data from the New York Stock Exchange. And, if you had to move 42 billion rows of data to a middle tier to analyze it, I think the results would be probably impossible to obtain. In this case, it happens in about 3 seconds. So that's the difference between having to move an enormous data set and not moving it, and also leveraging the power of the database. There are plenty of other examples, customer data, sales data, marketing data, where the reduction in data movement leveraged with the power of the database produced some tremendous results. In fact, we talked about the theory of simplification. Let me show you some real-world benchmarks when people are using these UDFs. And I'm certainly not going to cover them all, but I'll point out a few. Sears basically had this challenge in that they couldn't complete their market basket analysis in a timely manner. And as you can see here, using a third tier for SAS, it took 20 hours. Using UDFs, it took 2. So it's a humongous time savings for them, and allowed their servers, their SAS server, frankly, it took a huge burden off their SAS server and allowed them to run additional analytics using SAS. So in some ways, we're quite complementary technology to that. Humana also uses the models. They use them to score the quality and efficiency of care provided by doctors in their network. And they saw their processing time go from 6 weeks to 10 minutes. It's probably the most dramatic example we've seen. Here, because of the data set sizes, because of their SAS server size, and it doesn't just have to be SAS, it could be any vendor, what happens is they had to move 25 sets of data because they couldn't hold enough in the server to complete the calculations. Now they do it all in database. It takes 10 minutes. So went from 6 weeks to 10 minutes. And again, a tremendous savings. And I'll mention that they continue to use, in some cases, many of these companies have continued to use SAS as the front end. If you're a SAS user, they're writing proc SQL statements to run our stuff in database or to run CLR in database. Pretty impressive performance gains. I think you can see that there's some advantages there. I want to tell you that, that's the theory. Move less data, simplify your architecture, take advantage of your powerful database platform. CLR is kind of new. We just met with a healthcare company. They told us CLR is not allowed in their organization. I think we've come across that before, and we'll see it. We're seeing it change right now. So I show this slide to sort of tell you that, these are our clients. Many large companies, they're using this stuff in mission-critical production environments. I talked about Humana, but I'll talk about United Health. United Health is using CLR UDFs, basically, to analyze millions of rows of data with thousands of variables. And what they're doing is predicting chronic disease. In fact, in one case, they can predict the onset of adult diabetes within 5 years with as much as 95% accuracy. So I say that because there are other examples, but what could be more mission critical or important than predicting health care or preventing chronic disease? And that's where UDFs are being successfully deployed. Another example is Epsilon. They're using in-database analytics. In-database analytics is another term for UDF to analyze the behavior of more than 50 million people to build targeted marketing campaigns. And I think finally on this slide, one of the most impressive financial results is that Trident Marketing is using these things. In a 4-year period, there's a case study out that shows they realized 100% growth in revenue using UDFs. And the way that they did it was very different than what you see in traditional analytics. Traditional analytics is you got your data scientists, they do the math, then they produce the results and give it back to the business. What Trident did, because UDFs can be deployed widely in the organization, is they literally went from the front end to the back end of their organization, so a sales and marketing company, and they deployed analytics in each of the departments. And as they deployed those analytics, they saw gains in every place. And what they did is they deployed them within their Microsoft stack. So if you're in marketing, you got your marketing analytics. Then sales was able to benefit because marketing was more effective. Then sales got their analytics, and they became more effective. And then the delivery models that they use, the ways they deliver their products and services, also became more effective. When you roll all that up, that operationalized analytics, they realized 1,000% growth in revenue in 4 years. So I put that out there as, if you need something to convince your team, we can certainly help you with some of these case studies, that it's okay to use CLR, they're being used in really important places, and that the benefits can be tremendous. Finally, I'll just mention what people are doing, and again, I'm not going to cover all these, but these are places we've seen the use of CLRs, and there's a wide variety of applications. I mean, you can see here that it covers a bunch of different segments, and people are building them into their business processes. Just a brief mention on that. I want to show you lastly the value benefits, right? So these are real case studies from people using CLR UDFs. You can see that there's some pretty tremendous returns on investment there from what are incremental gains driven by the use of UDFs for analytics. And I think this slide really demonstrates the business value. So I think from the first part of the presentation, we've covered the theory behind it. We've covered the business benefits of using UDFs. But let's now dive into the technical side. I'm happy to answer any questions or provide any information about the information here, and also dive into any specific business cases or industries. But let's jump into CLR and see what we're talking about. So basically, CLR is it's common language runtime. It's a component of the .NET framework. It's used when you want to perform computations or when there's a need to leverage logical programming. I mean, T-SQL's been out for a while, Transact SQL, right? But it's really good for data access. What CLR is good for is when you need, like I said, the computations, or when you want to leverage some logical programming. And the beauty is it's managed code, and in that managed code are many types of functions. And we're going to cover these in a later slide, but just know that it opens up a whole world of possibilities for you. It was introduced in SQL Server 2005, but in 2008 they made some significant improvements to it that made it much more powerful and robust. In fact, we started building our library on 2005, and 2008 was released. We were building that in C. We scrapped the whole project and moved to C# to take advantage of the huge benefits that were available in 2008. So I'd say you definitely want to be on a 08 R. I'm not sure you need R2, but 08 or later to take advantage. The buffer sizes and a whole slew of things are vastly improved. So if you happen to still be on 05 and you want to leverage CLR, I'd strongly encourage you to move up. Let's talk about some of the benefits. It's just simply richer in functionality. There's a tremendous set of, if you look in MSDN, you can see it. It's a huge set of features that you can take advantage of. And since you can build program logic, you're using managed code. I mean, it's really just powerful because the code management is a huge time saver over what would have happened before CLR allowed this, which would have been you would have written unmanaged C code and deployed it in your environment. This is managed code. It's much safer. It's much more powerful also. When you deploy it, you get high performance, you get scalability. The thread and memory management is already taken care of for you. Memory leaks are contained. Operations are controlled by the code access security. And finally, in this case, there's no cube required. So those are some of the brief benefits. I think when you add them up, there's a huge gain in deploying these. I think the security, the fact that it's managed code is just so helpful because it lets you inherit things that you'd normally have to build. I'll just show you very briefly some terms that we are going to cover, and I just wanted you to be aware of those terms during the discussion. There are a couple of things, there's more obviously, but there are certain functions that we leverage and deploy often. There's user-defined types, and what these do is allow you to create like an alias or a type that is bound, and you do that and create an assembly. Now, there's scalar functions, which is a type of UDF that returns a single row. There are table functions, and they return tables. Aggregate functions let you basically aggregate, but again, return a single value. And of course, stored products can return tabular results and invoke DDL and DML statements. We use all of these in our libraries, and they're all different types of functions you should be aware of if you're going to use and deploy CLR. I think with that, what we want to do is I covered the theory, covered the business benefits, covered a brief overview of CLR. I mean, we could have spent a whole session on getting your environment set up and all that, but what we want to do is dive into the business cases. So here, what we're going to do is we're going to show you how you enable and run CLR, and we're going to show you how to build one. Alex is going to build one and demonstrate it, and he's going to run it. It's very simple, but then you can see the concept of how it works. And then after that, we're going to show linear regression on a pretty good data set. I think the case is that we're going to show marketing effectiveness. And then we're going to show a CLR-based recommendation engine with an Excel front end. So here, we're going to demonstrate how you can use a front end tool to leverage the power of these in-database analytics. So I think with that, I'm going to hand over control to Alex and let him guide us through the world of CLR.
Thanks, Mike. Hi, I'm Alex DePally. I'm a relatively new addition to FuzzyLogix. I'm not a product engineer. I'm just a kind of a quant, but I'm here to just show you how simple it can be to build your CDRs and deploy them. Let's see if I can get out of this. So what we're going to do is we're going to get into Visual Studio, and we're going to kick off a new project. And we're going to choose a Visual C# project. I'm just going to link to my database. Obviously, it'll be different for whatever you're doing. I think that I need to move the screen here. And we need to specify a target framework that's compatible for us. So we're going to go with .NET Framework 3.5. Okay. And next step is we're going to add a new item. And that item is going to be a user-defined function. So in a couple of keystrokes, we're really at the build phase. We're really into our, where we're going to actually do some coding. I've pre-canned a bit of code that I'm going to use here. And so this is a very simple function we're going to create. I think we'll just change the code here and create a subtraction. This obviously isn't something you would spend time doing, but it's just an example of how simple it is to code up a UDF and get it to do what you want it to do. We're going to go into our build. We're going to deploy a solution. If we did it right, it's going to tell us we succeed in a couple minutes. Okay. We didn't. Let's see what happened. Probably didn't like the fact we may have already had one in there. So I've just gone over to SQL Server and eliminated a function I had built before with the same name. We're going to run it again. Okay, so we succeeded. What we've done is we've worked in Visual Studio in just a couple of moments. And we've actually constructed a function that's now residing in my SQL Server. If I go ahead and update refresh my library, I'm going to see under Programmability, Functions, this is a scalar function. There's the difference demo that we just created. Let's just see it work. And this is the whole power of these things. I'm putting that function straight into the data step, into the select statement of my SQL code. So we're just going to take two numbers and subtract them. Run it. And there we go. So we had a very simple function, 100 minus 80. You see the result. It's 20 in the results block. So the point is that whatever functionality you want to construct can become embedded as a function call that you can use in your SQL code. And of course, you can spend time constructing your own functions, or you can use the library of functions that we've already constructed for you. So I just wanted to show you some of those. So under functions, we have table functions, we have scalar functions, a whole library of analytics to perform on your data sets. The value, of course, is all the things Mike mentioned, the scalability, the security, the synchronized threading, and also the fact that you don't have to worry about getting the computation right because we've already done that for you. Any questions, or Mike, do you want to jump in and add anything at this point?
No, I really appreciate that. I think it's key to see that you know, you can easily build simple CLRs, and you should. In fact, it's great to be able to push down this logic into the database and have it so easily accessible. I think it's, you know, we chose a simple example so you could see how it ran. You know, the power of it is taking business logic and pushing it down in there and running it. And then, of course, like Alex said, you know, we have hundreds, probably at this point over 500 models that run in there. So you can build all sorts of things. You can build classification models, data mining models, segmentation, simulation, forecasting, or you can build, you know, existing business logic that might be proprietary to your company, but you want it to execute in the database versus executing in some other piece of the environment. So that was really great. Thank you.
You're welcome. So a little bit more meaningful demonstration about the power of these functions. So we're going to do a regression. We preloaded some data and transformed it for use in this analysis. And we've got our linear regression function from our FuzzyLogix DVLytics library. And we've told it to pull from a data set that's got 1 million records. And we need to enter a couple parameters, the observation IDs, the variable IDs, and the values. And then we've indicated with the one that we want to intercept as we do our regression. So we're going to fire it off. And this took us 5 seconds to get our 1 million rows. Let's blow up this results screen here. There's messages so we can see our output. Didn't quite get it that time. There we go. So we're seeing that in this manufactured data that we've concocted, we had an 85% R-squared for a model that had 3 independent factors. Coefficient ID 0 would be our intercept. And then we saw that our number 1 factor was highly statistically significant. We had a p-value of 0. The other 2 factors in our model were contrived to be random, so we're not seeing significant p-values there. So the idea is a simple one. We've built a regression function that you can put right into your SQL call. So as you extract the data, you don't actually extract it. You actually run it through the function, and then what you do is you bring back the results. And so as Mike said, you're not hauling data around. You're performing the analysis on the fly. Mike, should we take any questions at this point? Or?
Sure, we can take questions here before we go to the visual, and I'll mention that, you know, in this case we had the 3 variables, and a good example of using something like this would be, say, marketing wanted to know, okay, I contact people in multiple ways. I may email them directly. I may do direct mail. I might do banner ads and keywords, and I've got a new product I want to offer or some new type of thing that I want to prepare. So what's the best method for me to reach out to my customers? What's the most effective method for me to spend my marketing dollars? I mean, that's just one simple example. There's hundreds of others, but it's something that this is something that's simple enough that business users want to use, and what you can do is create your own report, have it dynamically pushed down into, which we'll see in a minute how that dynamic push down works, have it dynamically pushed down into the code, and then in this case end users can run their own analytics. And that's really powerful, because I think what you'll find is that there's not enough data scientists on the planet for the demand. They typically have a huge queue of things that they're doing, and this is really liberating for them, because often forecasting is probably the best example, where they run forecast one way, then an end user says, well, I need it for my group or my product or my time period or my geography. Right now what happens is the data scientist or the person with the access to the analytics has to configure and run that model. But with using this type of technology, you can have your end users easily be able to select, okay, I want to forecast product 1, 2, 3 in states 3, 4, 5 over time period X, Y. And whatever they choose, it just runs it immediately and presents the result set. I mean, these are the results that we get, but obviously using a reporting layer, they can be simplified and provide guidance. So I guess long story is the benefit here is that very, very easily you can push some of the analytics, especially routine analytics, out into the end user community. Give you 2 examples where that's been successful. There's many more, but 2 I'll mention. The Humana case study we talked about before was where people want to know what is the quality of care and the efficiency of care of doctors in my network. So in other words, I'm Humana, I'm paying this money. Are the doctors I pay providing quality and efficient care? Before they ran that job in 6 weeks because it had to be run by the IT team and the data scientist. And they could only run it twice a year. So twice a year they could ask the question, are doctors providing efficient and quality care? Now they do it on demand. Their end users run it on demand. And that has greatly reduced their risk in their portfolio and allowed them to be a better administrator of their network. The second would be Jim Beam. Exactly like this, except it's forecasting. And the way that works is they have hundreds of products, and they have a massed, complex, vast array of ways they market it. So at Jim Beam, let's just say you have product 1 only for North Carolina. The person beside you has 10 products, but only for the chain Chili's. The person beside them has 3 products, only bourbons, only on the East Coast. It's all sold and marketed that way, and it's a complex environment that's successful for them. Their sales, more than 50% of their products vary in volume more than 25% a month. So it's unbelievably hard to forecast if everybody's running around using different types of models. Given the variableness of their data, it's already hard enough. So they took this, they built in database analytics exactly like Alex is showing, and they have a front-end tool. And end users go in there and simply select products, geographies, time periods, and push a button and get their own individual forecast. So 2 examples of how what Alex showed you here can be used directly by the business users. I feel like there are probably some technical questions out there as well. So if you want to raise those questions or put them in the chat window, we'll be happy to answer them. Melissa, you can let us know, or if you'd like Jim to go ahead and do the recommendation.
Yeah, I have 2 pending questions. One's just a clarification. It appears this takes place of cubes, but the person wants to know if it also takes a place of the data warehouse as well.
That's a good question. So probably the simplest way to explain it is when you buy SQL Server, you have a data warehouse and you have native functions. And inside SQL Server already delivered are things like sum and average. Now, if you want to do something a little more esoteric or apply some different logic, what a lot of people do is they create a cube, they store a subset of their data in it, probably aggregated and prepared, and then they allow some reporting to come off that cube. What we're doing is we take hundreds of algorithms, or what you could do if you build your own CLRs, UDFs, is you could deploy those inside the database. And Alex, if you can go back to the table functions or the aggregate functions maybe in the DBlytics database, the larger list. Once you deploy or create these CLRs, they're actually resident inside the database. They're living inside the database, and the kernel, the system sees them as native functions. So here we have a bunch of scalar functions. These are a bunch of distributions for simulation, but you can see also things like cosine. If you scroll down, Alex, there's some more common things like correlation or segmentation, where you can see k-mean segmentation and things like that. So these models are actually living inside of the data warehouse. And where they're running is when you execute the SQL statement, it kicks off a thread that the kernel manages. And in this case, what's happening is if you run, say, correlation, the code is managed code by the database, and it's executing deep in the database, leveraging all the available capabilities. So all the multi-threading, the parallelism, all that that's available is being leveraged inside the database. So it doesn't really eliminate the data warehouse, it enhances it because the CLR code is extending the use of that database, if you will, to now become your location for analytics. Hopefully that answered the question. It eliminates the cube because you now don't need that environment to do this type of processing. Some people actually do some processing in database and send the result set to the cube because all their reports already point there. Others start to reduce the size of the cube. Sometimes cubes become performance bound as the data sizes are growing. So this is a nice way to have balance. In some environments, you have both. You have in database and you have the cube. But I think the data warehouse is absolutely required because that's what's actually managing the code that's executing.
Okay. The second one, you had mentioned that you tested all of your 400 to 500 models. Person wanted to know at a high level, how did you validate these different models?
It's a very good question. We test them for a couple of things, right? Speed, scalability, accuracy. So speed and scalability, we can show that. The accuracy, what we do is we have environments that run both R and SAS and MATLAB. And what we do is we test the output of our models using the same data against those three. Now, without getting too technical, there are occasions when there are slight differences, but that's because MATLAB may have coded one version of something esoteric like support vector machines and SAS coded another, and the outputs are slightly different. But the accuracy of the outputs, in other words, here you can see on the screen like you have R squared, adjusted R squared, the standard error, the residuals, the different values, the F-stat, the P-stat, all those values are tested against R, MATLAB, and SAS for accuracy.
One final one. Will this impact the performance on my database?
We get that question every time, and it basically works like this. If you execute a SQL statement with 100 joins from, with 1,000 variables, your database is going to have to focus the performance on that to the limit that you've set it, right? However you've allocated your resources. This is exactly managed the same way. So the beauty is the database sees this as a simple or complex query. So what I mean to say is if you ask a question that says, I want to do a correlation of 10,000 items. We have a customer that does it with 80,000. So their correlation table is 80,000 by 80,000. Absolutely, the database is going to have to manage that process and run. Is it going to be a little hard? It's going to run like a report, right? But mostly no one asks a question that hard. And the reason I mention that it's exactly like when you execute a SQL statement is if you're good at coding the SQL and managing, just like you wouldn't let an end user go get 30 years of data in a report, probably, you're not going to let them do 30 years of analysis. So the beauty of managed code is that the database is managing it all. First of all, it's not going to let it get out of control. Unmanaged code can take total control, and there's a lot of risk in it. There's memory risk, there's performance risk, but now with CLR, being built into SQL Server, it really helps manage that performance. We've never had a client buy more space or hardware or processing power because they're using CLR. We have had customers buy bigger environments because their end users have asked them to get more and more types of analysis. But we've never, ever had anyone buy more hardware for this. In fact, you can turn on your processing monitor, and if you run a standard report, you see a little blip, and then if you run one like this regression, Alex, it took a couple of seconds, 5 seconds, you wouldn't see a 5-second blip. You'd see a little blip where the disk was spinning around for a data prep, and then you'd see a little blip for performance, and that would be it. It's extremely minimal. Long way to say that it's managed by the database itself, so it doesn't get out of hand, and it's also very minimal impact. If you don't have other questions, I think the next demo is pretty fun, and I'd encourage the community to suggest a movie they may want to see this run in. I'll hand it over to Jim. We're going to show a movie recommendation engine, and I want you to think about it like, based on what people's behavior is, what is the next likely movie they would watch? This is a very simple way to demonstrate next likely purchase. Next likely purchase is literally, hey, this person bought these 5 products. What is the natural 6th product for them to buy? Not based on what marketing thinks or product, but based on what other consumers like them have bought. So, Jim, if you want to show the movie recommendation, maybe people can, oh, I see one, Breakfast Club. Okay, we'll give it a go. Go ahead, Jim.
Okay, great. Thank you very much, Mike. Hey, my name is Jim Zhang. I'm the Chief Analytics Officer of FuzzyLogix, and I work with a lot of analysts from different various type of background. And a lot of the analysts are very technical and comfortable with writing code and such, but some of them are not very comfortable with writing code and prefer to work with dashboards and reports and beautiful interfaces and such. So the next demo that I am going to show is trying to illustrate the point that these kind of analytical functions that are embedded into the database are very easily can be done embedded into analytical applications that are created using some sort of GUI interface that don't require these type of coding that you just saw a minute ago with the CLR and such. These are completely insulated into the underlying application, and then for the users to invoke these things, all they need to do is to click buttons, and it'll generate the reports and the analytical results that they need. And so this demo in particular is, as Mike was saying, using some sort of Netflix movie data, and we have about 18,000 movie titles in here, and about 1 million users have rated these movies based on their experience using a scale of 1 through 5. And in collection, we have about 100 million ratings. So we're looking at a decent size amount of data. And using these 100 million user ratings, we created this application. And what this application does is that obviously it's created in Excel spreadsheet. And what it does is that it allows the users to search the database for one of the underlying movies. And based on this movie, which presumably the user likes, we can make several recommendations as to what are the other movies that you will likely enjoy. And so obviously this kind of logic can be expanded to a lot of other analytical applications, such as a bank might be able to use this to cross-sell other products. Another example is that the retailer could be also using this to identify the next likely purchase. They might, for example, use this to recommend what, after a grocer, after a customer finishes his grocery, he might get several coupons, and the retailer might use these to recommend what kind of coupons to print for the customer. So there's quite a few of variation of this type of applications that we have embedded, in our customers' application. So with that, let me put in let me just show you, how this works, and then we'll take we'll take several movie titles that folks wanted to try. So what I have on here is the most popular movie that people ask me to try. It's Godfather, and so I will first click the search button, and it will search for the movie titles that contains the word Godfather in it. And so there's 8, as you could see, there are 8 movies found with this search criterion. This is, by the way, going back to the database I searched for this movie title within that 18,000 movie titles. So we'll choose The Godfather, and now we'll click on the find. Now this find would basically go off and invoke a pairwise correlation calculation based on all these 100 million ratings. Using that pairwise correlation calculation, it would search for the ones that they're closest to this Godfather particular movie, and the ones that we see that coming back are Goodfellas, The Godfather Part 2, The Silence of the Lambs, Pulp Fiction. So guys that are really in favor of the movie could tell that these are pretty reasonable choices. And okay, so that's kind of the main idea. And now let me type in this suggested movie title. Mike, I think you said Breakfast Club.
Right.
Now,
come up with one of the chats.
Okay, cool. So let me search. Sorry.
Spelling on the. I can see it on your screen.
Okay, breakfast. Yes, there you go. So the spelling check passes.
Typing and talking at the same time.
and we need a spelling check for Excel, I guess. Okay, so we came up with one match, and that is precisely the Breakfast Club. And now if I try to search and again invoke the pairwise correlation calculation and come up with the recommended results, and we see Ferris Bueller's Day Off, 16 Candles, Stand By Me, Pretty in Pink. I am pretty bad with movies. Mike, have you watched this movie before? Does that sound like reasonable list?
Looks like the whole John Hughes catalog there. He's a pretty famous director of this group of movies. I think it's definitely believable. Melissa, I don't know if you have a choice or if you have other selections. I can't see all the chats, but I think you can.
My cousin Vinny was another.
Yeah, go for it.
Yeah, so I wanted to mention this while Jim's doing this. We're running this on a laptop. The instance of SQL Server we're doing this demo on, and that we showed the regression on the large number of data, I think there's 1 million rows, and this huge data set Jim's talking about, this is all being run on an i7 laptop with maybe 8 GB of memory, so single processor. So it just gives you an idea of the kind of performance you can get. I mean, here he's going through 100 million rows. So yes, it's my.
I think I see another chat requesting Pulp Fiction. So let me just put that in, Pulp Fiction. Okay, search for that, and let's see, Pulp Fiction and bonus. So this is the one that I need. And now let me click the Find button, and it should come back with some movies. And there you go, Reservoir Dogs, American Beauty, Fight Club, The Silence of the Lambs, The Usual Suspects.
Hey,
okay.
Hey Jim,
yeah.
Do farthest. Yeah. Now just
Again?
click farthest. Just click farthest.
Oh, farthest? Okay,
for everyone on the call, this is Netflix data, and so you may recall the Netflix contest. So farthest is the opposite. Show me the movies. So I'm hoping to see Bambi or something here. But yeah, so there you go. I would believe that Super Babies, Baby Geniuses 2 is about as far from Pulp Fiction as you can get. But the idea there, folks, is that we just build a recommendation engine that marketing can use. We've built these with music and all sorts of other things. And the key concept is that if you had to move 100 million rows of data and maintain it over to a middle tier, first of all, it gets complicated, and you have all this double duplicate storage and security layers to manage. Here we've got everything directly in the database. I think if there are other movies and questions looking at the time, I think if I can wrap up with the last slide, Alex, then we can go directly into any questions. I mean, I think what you can see is the benefits, that you can take a front-end tool, you can process this enormous amount of data, and hopefully we were successful in the demo of showing you, how to do this. I mean, it was a little fast on how we built it, not because Alex went fast, but because we have a limited amount of time. Happy to get into more detail, but in summary, what I'll say is that, okay, this stuff's being used by large companies in many business critical situations, and the use is growing. We talk to people every day about this. What's true and what we've shown too is that there's high ROI in using these, and that they're powerful and flexible and allow you to write logic and perform computations using managed code. I think you can see the performance and scalability. Like I said, that was a 100 million row calculation, performing pairwise correlation on a laptop. I mean, that's not too bad considering there was zero data movement. So the data movement was, what is the movie into the database, and the result set that came out was that short group of movies. And the nice part, as we've shown, is you can build it into any kind of front-end device without having to ask your end users to adopt some new type of front end, right? They already have plenty on their desktop. And I think finally you can see in the example that they're easy to build. Now I will tell you that the way we've built it is because we're a bunch of parallel programming math geeks, right? So we've built this stuff to run very, very efficiently, and where possible we've parallelized the math. So you do get some tremendous execution out of these. And hopefully, that's kind of clear what CLRs are, what's the theory behind them, what the business case is, how they work technically, and how you can use them. We've got a few minutes, Melissa. I don't know if you have other questions. I'd be happy to answer them.
I don't have any further technical questions, so if there's something else that you want to, add to this, I do also want to make a mention that the slides and the recording for this session should be available within an hour, and I will, in the chat window, give you the quick URLs for that. We'll also have it on the PASS BAVC Twitter handle. So it'll be out there probably the quickest. I do actually have a couple more questions that are coming up. It says, how do end users invoke the predictive analytic model?
So the access method for all the analytics is SQL. And so if I split them into tiers, right, the data scientist is going to write the SQL statement, right? If I move up the tier to like business analyst, marketing managers, they're going to take any front end that they have. So if they're using reporting services, if they're running MicroStrategy, Excel, whatever the current environment is, Tableau, where they already have their existing reporting, all you simply do is just like your report would say, hey, select sales for January, February, and March in North Carolina, Virginia, and Texas. You would simply say, hey, forecast sales using those same parameters. So literally what's happening is the end user, that someone technical in the IT department will build the model in a way that the end user front end tool just passes parameters down to that model. So it's just simply a dynamic SQL statement. If for data scientists and other people who know SQL, they can obviously work directly in the SQL layer. But for business users, it's really easy to embed it directly in their tools, and it's powerful. We talk to a lot of companies. We do a lot of analytics consulting, and companies want analytics, but the truth is, if you turn on 100 analytic models tomorrow, you're operationally going to be able to digest about 3 of them a week, maybe less. right? If you think about the fact that I might give you a very accurate forecast, but what will you do with it? Their business change, and there's this adoption curve with analytics. As the 71% getting into it, what's going to happen when you do analytics is the math is going to tell you something that your business intuition won't let you believe, right? Because there's a pattern in the data that your intuition says, I challenge that pattern. Now, the beauty is with our technology, or with CLR UDFs that you deploy, is you're letting the business slowly digest and operationalize these analytics and become to believe that analytics really aren't the answer. They're a part of the toolkit that helps you make better business decisions. And so that's one of the real benefits, is having those end users run their own, but in a way that you grow them in your organization so that they can be digested. Hopefully that covered it. Melissa, did you have another question?
We actually don't have any further questions at this point. I guess we should close out the session. And I just want to thank you guys for providing us with such a wonderful presentation, and it was great to hear a variety of presenters from your side on this. So again, within an hour, I'll probably have the links out there populated so you can get to the slides and the recording of this. Thank you very much, Mike, Jim, and Alex.
Thank you. Thanks, Melissa. Hope to see everyone in Charlotte. Bye-bye.